All right, let's get started with part 2 here of 2.6. Okay, so after that first video, maybe you're still a little confused, but hopefully after watching these 5 examples, you will feel a little more comfortable graphing by translating. Okay, so let's go ahead and continue. Take notes, have your phone ready in case you need to message me any sort of questions while you're watching these lectures. Also, if you haven't noticed yet, if you need closed captioning, down at the bottom of the screen, if you mouse over, you'll see a little white rectangle with the letters CC, so you can get subtitles. Okay, so 2.6, part 2. Okay, so here in this video, I'm just doing the 5 examples. Okay, so remember we have, if you have addition or subtraction outside, okay, outside the parent function, then that is a translation up or down. If you have add or subtract a number inside the function, that's a translation left or right. And then if you multiply a parent function, then you're either stretching it or shrinking it or flipping it. Okay, so let's take a look at this first example. Let's go ahead and graph y equals x squared minus 1. Okay, so hopefully you recognize that the parent function is x squared, and we are subtracting 1 outside the parent function, not inside. Okay, so remember, this is outside the parent function. This is inside the parent function. Outside is an up-down shift, and inside the parent function is a left-right. Okay? All right, so this one here tells me that this is going to shift down 1. Okay? So I'm going to take the parent function of x squared. Hopefully you have it memorized. And we know that, let me do this. Okay, I will use red dots for the parent function, the points for the parent function. So we know these are the 3 original points of the parent function x squared, right? And you don't need to do the full graph, but I'll do a dashed graph so you can see sort of a ghost of the parent function. Because remember, we are graphing this here, which is taking the parent function and shifting it down 1. Okay, so here I will go ahead and do my final graph where I shift this parent function down 1 point, and I'll do it in black. So I'm going to take all 3 of these points, and like this says, I'm going to shift it down 1. So this here will shift down 1 to right there. This point will shift down 1 right there. And this point will shift down 1 to right here. So this graph is now the graph that we want, x squared minus 1, which is parent function x squared shifted down 1. Okay? All right, let's take a look at another one. Let's go ahead and graph y equals absolute value x minus 2. So hopefully you recognize the parent function. The parent function is the absolute value graph, which is the V shape, right? And now this is inside, so this is a left-right sort of translation. And this is the one that's counterintuitive. So this one is to the right 2. Okay? So again, This is outside the function. This is inside the function. Okay. Inside the function is a left-right shift. Okay. So again, I'm going to plot the parent function, the v. The original parent function, I'll use red. And the original parent function has a point at 0, 0, 1, 1, negative 1, 1, and it's v-shaped. Okay. And I'm going to take that parent function and I'm going to shift it right 2. And I will do that in black. Okay, so take all 3 of these points and we're going to shift each one to the right 2. 1, 2. So we get a point right here. This one at 0, 0 will go to the right 2. 1, 2. And then this one over here will go to the right 2. 1, 2. Okay, so this is now the absolute value graph that I want. Okay, so it's the parent function, absolute value of x, shifted to the right 2. Okay, and let's take a look at the transformation where we have to multiply. Okay, suppose that I want to do this graph, y equals 1/2 x cubed. Okay, so this is a multiplier. And we said this will either stretch it or shrink it. Okay, if it's a number bigger than 1, then it will stretch it. Okay, if it's between 0 and 1, like 1/2, it's going to shrink it. Okay, so we are going to multiply the original y values. Okay, so, and the parent function is the x cubed graph, is x cubed, which is the snake. So let's go ahead and plot those 3 original points. Okay, I'll use red for the parent function. So we have a point at 0, 0, 1, 1, negative 1, negative 1. And if you remember, it does this sort of snake. Okay. All right. So what happens is these 3 points have an x and y coordinate. Okay. Some students have a hard time seeing what the y value is. So like this one here, its y value is 1. This one has a y value of 0. This one has a y value of negative 1. Okay, so here, let me just label these x and y. All right, so it's important for you to know what the y value is, because what happens is when you're multiplying a parent function by a constant, you end up multiplying those original y values. This one has a y value of 1, this has a y value of 0, and this has a y value of negative 1. And so their x values don't change. They're only their y values. So right here, you're going to stay at the same x value. Your y value will just be different. So you have to find out, oh, okay, does it go way up here? Does it go down here? Where is it? And the way you find out is by multiplying its y value, 1, times this constant, 1/2. Okay, so 1 times 1/2 is 1/2. Okay, so its new y value will be 1/2. Okay. The x value doesn't change, only the y value, okay? This one, the y value is 0. 0 times 1/2 is still 0. And then over here, this y value is -1. So when we multiply -1 times 1/2, we end up with -1/2. So that's where it is. So what happens is this parent function, this red one that you see, the y values all get cut in half, multiplied by 1/2. So they all get cut in half. So it's like this red graph here gets squished. Okay. So you get something like that. Okay. If you can't tell what the y value is, then make your table. Okay, the 0, 1, -1, and write down your y values. Okay, and then multiply them all by 1/2. Okay, so this will be 0, this will be 1/2, and this will be -1/2. Okay, so that's going to be your new point: 0, 0, 1, 1/2, -1, -1/2. But you should be able to just see it here. Y value 1, 1 times 1/2. And remember, our original points, they're either going to be 0, 1, or -1. So to multiply a constant by those original y values it's going to be easy. You should be able to do it in your head. Okay. All right, let's take a look at another example. So all three of these examples here have only one of those translations or transformations. This is just a shift down one. This is just a shift right 2. This is just a transformation multiplying by 1/2. Okay, so let's put all three of them together in one problem. And let's go ahead and graph this. Y equals -2 times the absolute value of x plus 1 minus 1. Okay, so we see we have all three of them now. This one's a up down, this is a left right, and this is a stretch or a shrink. Okay, this one's outside, so this is a down 1. This is inside, this is a left 1, and this one is multiplication, and we only multiply the y values, not the x values, the original y values. Okay, so it's important for you to write down your analysis of the equation so that you know what to do with the parent function. What are we going to do with it? We're going to take the parent function, which is the v-shaped graph, and we're going to take those 3 points. And first so when you have all three of these, whenever you have this one, you always do this one first, because you have to multiply the original y values. If you start shifting them, then you're no longer at the original y value. You're at some new y value. Okay, so do this one first. Okay, so let's go ahead. All right. Okay. All right, so let's go ahead and do the parent function in red. Okay, so absolute value, the parent function is the V shape. Okay. And to keep this a little clean, I'm not going to do the dashed graph, because then we might have too much going on in our drawing here, and it might get a little messy. Okay, but you could try to imagine a dashed V here. Okay, All right, so I'm going to start with this right here. Multiply the original y values by -2. And then when I do that, I'll do it in green next. Okay, so again, the y value here, 1. 1 times -2 is -2. So I'm going to go down here to -2. That's the new y value. 0. 0 times -2 is 0. Over here, the y value, 1. 1 times -2 is -2. Okay, so you can see here, whenever you multiply by a negative number, it's going to reflect your parent function over the x-axis. It's going to flip it, okay? So if this were the x squared function, it would have been an upside down u. All right, so now that I have these 3 points, now, and try to imagine a dashed V here in green. Okay, now I'm going to go ahead and do my shifting. My left one, down one. And I'm going to do that with these, and I'll be done. Okay, so I'm going to use black for my final graph. So all of these are going to go left one, down one. So starting with this one, left one, down one. The next one, left one, down one. And the third one, left one, down one. So now I have these 3 black points, and I know it's an upside down V. So now I can go ahead and graph it. Okay. So that's how you put them all together. Again, if you ever have this one in combination with any of the others, do this first. Okay. All right, I'm going to have you guys try this last one, which is the one that was in at the very end of the notes in part 1 video. Okay, so let's see if you can do this. Go ahead and graph. Y equals negative absolute value x plus 2 plus 3. Okay, so this is a -1. So if you need to have a number there, an actual number to see, you can put a 1 here. So that's a -1. Okay. All right, go ahead and hit the pause button, and you can unpause it step by step to see if you're doing it correctly. Okay, so maybe go ahead and analyze this and see if you can identify what sort of shifts are being done here, what sort of translations and transformations are being done, and then unpause to see if you have that part correct, and then pause it and then start again. Okay. All right, so starting with our analysis here, we know that here we're going to multiply the original y values. Okay, and this is what we're going to do first. And then we can do our 2 shifts. This one is inside, so that's to the left 2. And this is outside the function, the parent function. So this is up 3. Okay. And you should have gotten that right because that was in your notes. And that's as far as we went with this problem in part 1 video. So now we're going to actually graph it. Okay. Okay, so the original graph, I'll do it in red. Original graph is absolute value, which is the V shape, 0, 0, 1, 1, negative 1, 1. Okay, I'm going to multiply the original y values by -1, and I'll plot those in green. Okay, this has a y value of 1. 1 times -1 is -1. This has a y value of 0. 0 times -1 is 0. So it stays. This has a y value of 1. 1 times -1 is -1. So here's -1. Okay, so we finished this one. We multiplied the original y values. So now we're going to take the 3 green points and we're going to shift them 2 to the left and 3 up. And that will be our final graph. So I'll do it in black. All right, so left 2, 1, 2, and up 3, 1, 2, 3. Okay. Do the second one. Left 2, 1, 2, up 3, 1, 2, 3. Okay. And then this one as well. Left 2, 1, 2, up 3, 1, 2, 3. Okay. So we have that, these 3 black points. So I'm going to go ahead and do my final graph. Okay, so that's what it should look like. Again, if you have any questions, make sure you text me or email me. You can always ask me for another video. You can ask to meet with me. Okay. All right. So that does it for 2.6. Please keep up with your homework. I'll see you next time.